Number 11, if f double prime is x times x plus 1 times x minus 2, then the graph of f has inflection points when x equals. So first of all, we have inflection points wherever f prime is 0 or undefined. First of all, this is a polynomial function in factored form, so it's never undefined. And it's going to be 0 at x equals 0, -1, and +2. Now, there's more to inflection points than just that that's when it's 0 undefined. It also has to change sign at that point. So let's see, I'm going to plug in -1, I'm going to plug in 0, I'm going to plug in +2. The next thing I'm going to say is back here, anything squared is always positive. So this piece here is 100% of the time going to be positive. So I just have to worry about the others. So take a number less than -1, like -2. This becomes negative, this becomes negative, and the whole thing is positive. Take a number between -1 and 0, like -1/2. This would be negative, this would be positive, and so we come out with f double prime being less than 0. Should say double prime. Take a number like +1. We have positive here, so f double prime is positive. And if we plug in 3, we also get positive. So because there's a change here, then this is a point of inflection. There's a change here, that's a point of inflection, but there's no change here, so this is nothing. So we have a point of inflection at -1 and 0. All right, let's take a look at number 12. If g is a differentiable function such that g is less than 0, so g is negative for all real numbers x, and if f prime is x squared minus 4, which of the following is true? And so we're talking about relative maximums, relative minimums. So I'm going to go ahead and I'm going to find the critical number. So I'm going to set this equal to 0. And that would be 0 whenever, and I'm going to factor that into x plus 2, x minus 2. And it's times g of x. And so that's going to be 0 when x equals plus or minus 2, and when g of x, well, first of all, it's never 0. It's always less than 0, so we don't even need to worry about that. All right, so we have our critical numbers at 2 and -2. Let's make our number line, -2, +2. Let's take a number. So again, remember, g of x is always negative. And so take a number like -3. I'm going to actually plug it into this one. -3 squared is 9. 9 minus 4 is positive. So that means that f prime is negative here. Plug in 0. If I plug in 0, 0 squared 0 minus 4 is negative. Negative times negative is positive. And then take a number bigger than 2, like 3. 3 squared is 9 minus 4 is 5. That's positive. Positive times negative is negative. So because we're decreasing to increasing, that means -2 is a min, and then it's increasing to decreasing. That means we have a maximum, the relative maximum at x equals 2. So does f have a relative maximum at x equals -2? No, it does not. Does it have a relative minimum at x equals -2? Check. Does it have a relative maximum at x equals 2? Check. Seems like B is the answer. Let's just see here. F has a relative minima at -2, yes, but not +2. And it cannot be determined if f has any relative extrema. That is false. So B is the answer for number 12. For number 13, the graph of y equals 3x to the fourth minus 16x cubed plus 24x squared plus 48 is concave down. So again, concave down, I'm thinking f double prime is negative. So let's go ahead, let's find y prime. That's going to be 12x cubed minus 48x squared plus 48x. Y double prime is going to be, what, 36x squared minus 96x plus 48. What a gross problem. We're trying to set this equal to 0. I'm going to factor that out. I'm going to start with a 12. That's going to leave me a 3x squared minus an 8x plus a 4 equals 0. Now we try to factor. I know the firsts give me 3x squared, so that means it has to be a 3x and an x. I know the last give me, now watch this, a positive number, but the outers and inners give me a negative, so therefore it has to be a minus and a minus. And then now for choices for 4, it could be 1 and 4, 2 and 2, 4 and 1, but I want to get that 8. So how do we do that? If I try 1 and 4, my outers give me a negative 12, inners a negative 1, that doesn't work. If I try 4 and 1, outers give me a negative 3, inners give me a negative 4, that's negative 7, close, but not quite. And if we do 2 and 2, then the outers give me a negative 6, the inners give me a negative 2, that's negative 8, we're good. So that's going to be 0 when x is, we'll start with the easy one, positive 2. And over here, it's going to be positive 2 over 3. So we want to figure out where it's concave down. So we go ahead, put our numbers on. Take a number less than 2/3, like 0. If I do that, this 12 is always positive, so I don't need to worry about that. But I get a negative in here, a negative over here, so that combines to give me a positive. Take a number bigger than 2/3 but less than 2, like 1. This first factor here stays positive. The second one goes negative. So f double prime is less than 0. And then a number bigger than 2, if I plug it in, gives me positive, positive. So f double prime is positive. So f is concave down on the interval from negative 2/3 to positive 2. And that's 13. All right. Number 14, the graph of f prime. So again, f prime is what we're given. The derivative of f is shown above. The function f has a relative or a local max, relative max at x equals. So remember, we get a relative max whenever f prime is 0 and changes positive to negative. So if we're looking at this, f prime is 0 here and here, but it only changes from positive to negative at x equals 1. Number 15, the graph of a twice differentiable function f. So again, this is the graph of f as shown in the figure above, which of the following is true. So if I look at f right here, I know that f of 1 is 0 because we hit the x-axis. But the function's increasing there. So what else do I know? I know that f prime of 1 must be positive because it's increasing. I also know the function is concave down. So that means f double prime of 1 has got to be negative. So therefore, f double prime has got to be less than f, which has got to be less than f prime. And so D is the answer.